So far, binomials like n choose k usually meant that n and k were non-negative integers, and n choose k was just counting the ways of choosing k objects from n objects. But now we're going to generalize this, where n will be able to be any real number, and so we're going to write it in this way here, sort of like r choose k, but now for any real number r. And the way we generalize this, it's just going to be the product of r minus 1, r minus 2, all the way to r minus k plus 1. So you have actually k terms here. So you subtract by 1 k times, and then you divide by k factorial. Now, of course, if r is a positive integer, then this will just be the typical r choose k. But now we're able to talk about r choose k for any real number on the top. And there will be some benefits to this when we're looking at generating functions. Now, as an example here, so for example, you could compute what is minus 1 choose 3 now under this. Well, you start at minus 1, and then you go down by 1, so minus 2, minus 3, and you do this 3 times, so you get 3 of these terms. So you go 3 times down by 1, and then you divide by 3 factorial. And here this is just going to be minus 1. So minus 1 choose 3 will be minus 1. Another example is, what about minus 2 choose 2? So this will be something like minus 2, and then you go 1 down times minus 3 divided by 2 factorial. And this will just give you 3. So this is just to show, like, when these are negative numbers here, you can get a negative, you can get a positive. You can also be talking now about things like half choose 2, which will give you like half, and then half minus 1, which is just minus half. And so divided by 2 factorial, and this will give you minus 1 over 8. And you can have things like pi choose 7 and so on, right? Okay. So these numbers, they no longer necessarily count subsets directly. So instead, they're sort of like algebraic coefficients, and they're going to appear later in power series expansions, and that's why they're useful. And a particular useful case is when we're dealing with a negative integer on the top. So here, if n is a positive integer, and so when we talk about minus n choose k, this will have a nice way of writing it, which is just minus 1 to the k, n plus k minus 1 choose k. And like we said, this is going to pop up later in some important generating functions. So a proof for this, quite simple proof, is just writing out the definition. So minus n choose k, this is going to be equal to minus n minus 1 minus n minus 2, and so on. And you get k of these, so you go all the way to minus n minus k plus 1, right? And you divide by k factorial. Now, notice that since you have k of these, and you can factor out the minus 1 from each one of them, you'll get minus 1 to the power of k. And now you get all of these, but in a, I guess, in positive form. So n plus 1, n plus 2, all the way to n plus k minus 1 over k factorial. And now the idea is that if you multiply on top and the bottom by n minus 1 factorial, so if you do this, well, now the top here, you're going to have n plus k minus 1, and it's going to go down by 1s all the way to n, and then times n minus 1 factorial. So this will just give you, so of course you have the minus 1 k, and this will be n plus k minus 1 factorial over k factorial n minus 1 factorial. But this, so this of course will be minus 1 to the k, and this over here is just going to be n plus k minus 1, choose k.